Okay, so if you guys are wondering what would be the class or what would be the topic for today, uh, so we have done with routing. So I'll take up IP services. Okay, so the topic for today would be network time protocol. So from your syllabus point of view, it's a encore topic listed on 3.4, 3.4.a, which says describe network time protocol. But yes, in CCNP level, describe is actually not a right word. So whatever you know, you should know with a good flow on your commands, and you must know how it works. Okay, so I'll do a couple of lab, or might be I'll give the next half or the second half to you guys, so you can take it over. Okay, so I have one lab and kind of few things there like authentication, changing the version, so which you can take it over. Okay, fine. So let me tell what is NTP, where do we use NTP, what is the purpose of having this in the enterprise, how is it going to help you. Okay, so NTP, it's network time protocol. Okay, so in short we call it as NTP. So let's say my enterprise consists of 100 of routers. Okay, I have 100 of routers. I'm gonna write it in this way. Let's say I have switches uh, around 500 number of switches. Okay, I have a lot of other servers, might be thousands of servers. I have firewalls, might be 20 firewalls, and any other devices, like you can have load balancers, right? You can have a proxy device, uh, you can have access points, right? So these are all your network components. So let's say out of 100, okay, out of 100, if 5 are down for some reason, so what would be your troubleshooting step? So obviously you will open up this 5 devices, you will see what time it went down, what is the timestamp, what is the logs, or what is the error, or what is the syslog message that's associated with that particular timestamp, right? So if you open up any devices, you talk about any devices, any networking devices, if you most probably on routers, switches, firewalls, we have command called show log. So let me just place on ping. Hope I'm audible with proper audio. If not, then I'll just change the ISP. So am I audible? Was my voice breaking up? Yes, for was I all right, or there was a voice break? Okay. So okay, let me change this. Might be I get disconnected, so don't go anywhere. Okay, because changing the ISP might uh, break the Zoom for 1 second or something. But I'll just rejoin. Okay. Okay, looks better. Okay. So is it fine now? Good with everyone? Okay, great. Yeah. So let's say when my device goes down, so obviously we open up the device and we see show log to understand what went down. So let's say one of the interface was down, right? So what would be the next thing that you want to understand? So you want to understand on what timestamp did this device go down, right? So the timestamp stamp is very crucial or very important. And let's say uh, out of these 100 routers, 50 routers had a proper timestamp, and the rest of 50 routers were all outdated and might be some they are following some different timestamp. Now troubleshooting becomes very difficult, right? If let's say this is your server and you have a router. Now let's say this router is following some different timestamp, and this is following some different timestamp. Okay, and if you just are trying to troubleshoot, you're trying to see the logs, you're trying to understand the logs, what time it went down, what time it came up, what time the routing protocol tried to converge. So basically if you see the logs on both of them, you will see timestamp is different. So let's say over here you have a different timestamp which is following UTC, and over here you have some timestamp which is following EST or IST. Now you need to sit and do the conversion. You need to go to some website, do the conversion, what is so and so, right? That becomes a mess while we have so many devices. So what we prefer is, we prefer having a unique clock, or I can say a unique time throughout your enterprise. And which protocol will help me? It's your NTP protocol. That's gonna help me. So how does this work? Should I configure this on every devices? Should there be some role model who will be serving as a source, and all other uh, components will follow that, right? So that's something which we have to see in today's class. So let's say I have a trusted source of time. Okay, so there are a couple of trusted source of time. Internet is one of them, right? There's something called as atomic clock also. We can also configure our own router and switches to act as one of the trustful source of the time. Okay, so let's say this is that person, or this is that component who is trusted. Okay, and this trusted will be connected to all other devices of our enterprises. So let's say I have routers, switches, servers, and all other things. So basically they send some packets. Okay, they send some packets and they start synchronizing, and so they follow a certain timestamp. Now design would not look like this, because having a cable between that trusted source and all your client, all these clients are very expensive sources, right? So we normally, what we do is, let me draw one three tier architecture. Okay, so let's say I have a core, I have a distribution switch, and distribution switch is connected to access layer switch. Okay, so I can place one of the NTP server here or over here, depends how big is your enterprise. Okay, so you have two possibility. Either you can place this NTP, it's your normal server which will have a third party software, or you can, as I told you, you can make your own router or a switch acting as a server as well. Okay, so what happens is they are now connected, because we are gonna keep them in a single subnet. Let's say this is all this subnet. Okay, and all these which are following the NTP, okay, 168.1.1, So basically they must be having that IP with them, 192.168.1.1, 192.168.1.1. So they must be in one single subnet. Okay, so what happens is we don't need any routing, we don't need any sorts of cables, or we don't need the infrastructure to be complex. Okay, so this is a simple way of configuring NTP. And in sometimes what happens is we can also have NTP referred to internet as well. Fine. So I'll tell you what are those trustful internet sources which we can use, and similar time we can also make use of one of our routers. So let's say in my lab I take this router as trusted one. Okay, and all rest of the devices are following the trusted one. But the question is, how is your trusted gonna be getting considered? Why don't you think the other devices can take the role of trusted, right? So anyone can take the concept of trust. So in the case of NTP, to define one of the component or one of the device acting as the trust, we have a concept of stratum. Okay, it's called as STRATUM. So this is a value which is gonna define who is most trustful. The lower the value, it's considered to be trusted. Okay, so it starts with 0 to 15. Okay, so in a networking components like network devices like router switches, they cannot be 0. Okay, we cannot achieve 0. So we can have anything 1 to 16. If you see 16, that means the clocks are unsynchronized. Okay, that means something is wrong with your configuration, or might be they are not synchronized, because the whole NTP sometimes takes up to 45 minutes to get synchronized. It's not that they are carrying some heavy packets or they take time. The working is something very slow. Okay, sometimes it takes 45 to 1 minutes to get see this synchronized status. Okay, but there are other commands which can help you to understand, yes, whatever you have configured is right and it's not wrong or something. Okay, so yeah, so this is the one value stratum which is gonna say who is the most trustful. So let's say I give the stratum value of 1 here, 2 here, and 3 here, and I have a switch. So who will the switch follow for your NTP or for your timers? It's your 1, the stratum value of 1. So this will get picked up because it's a lower one and this is preferable one. Okay, so let me show you the presentation which includes some key points which is which would be helpful from interview and also from certification point of view. So as I told you, NTP stands for Network Time Protocol. NTP is used to allow network devices to synchronize clock with central source. So you know who is central. So one who is having the lowest stratum value is something which we call it as NTP server, and this NTP server can have 2 ways to get the clock. So let me draw it over here. So let's say this is the NTP server where I configured stratum value of 1 and all rest of my devices are following this. Now how is this server gonna get the clock? There are 2 ways. One, you can redirect to internet clocks. There are a couple of internet clocks depending upon regions. Okay, or you can just change the clock setting of this hardware. So there are 2 ways to do that. Okay, internet of course will depend on internet. If there is a breakage, then might be all of the timers will go into toss, right? So prefer keeping it manually because manually it's more secure. Okay, so if I happen to show you the internet clocks, So these are those NTP servers. Okay, so you can find them depending upon region. So let's say this is for India. Okay, and I have some free server, so I can point my NTP source to these servers, and they will work as per the UTC those are being defined, or those servers are being listening to. So you have multiple of them. India is just one example. So if you see, if you just take out this IN, so you will see plenty of servers. Okay, so you can just take one which is nearby to you, because it's on internet. Latency plays very important role. Okay, so you can see here active servers. Okay, there are plenty of servers, and we can just point our NTP source to these servers. Or as I told you, you can just change the clock timer of that particular hardware itself. Instead of pointing towards some internet servers, okay, you can just go and change the hardware clock. So if you know show clock, there's a command to change that clock, and you can just set it. I'll show that. Okay, so you can do that. That's a better way to get it done. So where is this source dependent? Either on internet or its own clock. Okay, and this source is also called as NTP servers. So what does it say? So why do we make use of NTP? As I told you, it will help you to troubleshoot while you take the logging information of any outage, or if you want to see that BGP was down, so you will go to the show logs and you will see what time BGP went down. You will try to correlate this incident with some other issues. Might be if there was some ISP which went down, or there was some server which was having some bug and it went down. So you will try to correlate. You will say, yes, might be this happened because of that. So you need a timestamp, and a unique timestamp for, or a similar timestamp for every devices. Not that one has something and the others get something, right? So some similar timestamp on all the devices, and accurate date and time. So you might have seen some data center or some offices that date and time will be somewhere not synchronized one. Might be they are still on 1990s sometimes, but nowadays everyone start taking care of all this minor issues. I have not seen recently any devices showing this kind of thing, but yes, 5 years back I have seen many devices which were not taken care, and they were all showing some pretty very old date and times. Okay, so troubleshooting becomes very difficult in such devices. As I told you, they are gonna form hierarchical sources. Okay, so with this statement, NTP uses a hierarchical system of time sources. So that means there are a couple of sources that we can have it. Okay, so if I show you the diagram, something like this. So these numbers are gonna decide who is gonna get preferred. Okay, so stratum value 0 is something which we call as a atomic clock. Okay, and for a networking devices, we never point towards atomic clock, because they are fractions of milliseconds. The timers runs on fraction of milliseconds. So if I say atomic clock, you might have seen this, they are analog in nature. Okay, yeah, so something like this. These are atomic clocks which are analog, and they are considered to be the finest or the perfect timer in the world. Okay, and we cannot point our networking devices towards this, because the networking devices will then just have a lot of overheads just for the NTP synchronization, and might be then it's not able to deliver what it was supposed to deliver. Okay, so we will not point our NTP source to any of atomic clock. Okay, so stratum value 0 is considered to be atomic clock. That's why I said we will not use this. So we can use anything from 1 to 15. We again cannot uh, see 16 because 16 is a unsynchronized status. That means when the clock is dead, or let's say you just lost the connection. So let's say I was having a NTP server here, okay, and the NTP servers were connected to NTP clients. For some reason, let's say this link was down. So basically, you're reaching the you're having unreachability. You cannot reach to your server, right? In that case, on the client, you will see stratum value of 16 showing as unsynchronized. So that's a scenario when you cannot reach towards your server or this particular interface. Okay, that's unsynchronized. Or there could be one more reason that, as I told you, it sometimes take 45 minutes to get synchronized. So that could also be the issue. Or you can just try bouncing it, or you can try rebooting, and once they all reboot, you can see the clock getting synchronized. Okay, so there could be different issues here. So just don't decide by seeing unsynchronized, because sometimes the config will be good, the client has started taking up the clock what is given here, but still it might show you unsynchronized. So that could be because it's taking some time for synchronization. Okay, so yeah, so this is following some hierarchical orders. Okay, so I'll again once again come back to that. Okay, so we did this client and server architecture. So as you know, NTP is a server client. I would say server client. Okay, because we would have one server and the rest of them would act as a client. Okay, so basically they need to be synchronized, and this is gonna send those updated NTP packets, and they are gonna have a very similar clock timers whole throughout this enterprise. Okay, so they follow a server client model. Now NTP, there are two versions. One is version 3 and version 4. I'll talk about this in the next slides. Okay, so one is IPv4, other one is IPv6. One is what do you say, multicast, other one is broadcast. Okay, so there are few differences which I'll talk in few minutes. Okay, so there are two types, version 3 and version 4. The server is also called as NTP master. So remember this topic I'll discuss while discussing about the three different types of NTPs. Okay, NTP roles, we call it as NTP roles. So the first one is called as NTP server. A server is also called as a master. We have NTP server or client, and we also have something called as NTP client. Okay, might be this you are aware of this, but there's something called as NTP peer as well. Okay, so there are totally 4 roles, and I'll discuss each one of them, what is what. Okay, by default router works in NTP client server mode. So that means as soon as I configure NTP on my router, it will start working by default on the first mode, not the first mode, the server client mode, which is the second one. The first one was server, the second one was server client, third one was client, and the fourth one was NTP peer. Okay, so it will start working by default on this mode. So I'll tell you what is the difference between only this and this with respect to this. Okay, and what is stratum that I was talking about? It's reliability, it's the accuracy of your NTP source. Okay, so as I told you, if you have NTP source 1 or the stratum value 1, You also have a router with stratum value 2 and 3. So this device, whom is it going to follow? It's going to follow this router. The reason is the stratum value. The stratum value defines the reliability, accuracy. Okay. NTP uses 0 to 15 for NTP sources. Okay. 1 is most reliable, 15 is worst. 0 represent atomic clock, which is not used. I just showed you atomic clock is those analog ones. These are the valid ones, 1 to 15, and 16 represent not synchronized, which is again not good. So I would say it's 0 to 16. We don't make use of 0 because it's atomic clocks. 16 is a bad example. So the valid ones are between 1 to 15. So we can make use of anything between 1 to 15. Okay. And we can just set 2-3 different NTP servers. If one fails, we still have reachability to the second NTP sources. Okay, covered. And by default, when I have a router and if I configure NTP, it's gonna take this as the internal stratum value. Okay, so I told you that this is a NTP server. Okay, and we can have two ways of giving it a source or a time source. Okay, one was internet, the second was its own clock hardware, which I can configure manually with a clock command, and I can set it. So that internal hardware by default is gonna have the stratum value of 8. Okay, and all your next routers are gonna get stratum value of 9 now. Okay, so NTP also works on a hop levels, or you can also okay, so NTP works as a hop level. So this is my first hop, this is my second hop. If I had different devices, it would get 10 now. Okay, so basically what it says is, it says there are 2 hops now to reach to the NTP server. So NTP also act as a hop server, or you can also talk about like TTL. So it's just going increasing 1 plus 1. Okay, the best would be talking about the hops, like you have first hop and then you have second hops. If let's say you also had some other devices, it would get the stratum value of 11. Okay, so basically if you see the stratum value of 11 and if you happen to see the server is on 8, so that's nothing but it's so many hops away. That is you have 10, you have 9, and then finally 8. So it's easier in the case of NTP to determine how far is your client from your server, the main server. Okay, the best practice is keep those servers on a 1 hop away, maximum 1 or 2. Don't keep it very far away, because the stratum value is gonna increase. And what does stratum says? It says the reliability and accuracy. The more far away you go, the clock will start falling out. Okay, might be for some reason if the packets are dropped. Let's say if okay, let me say in this way. So let's say I have servers are connected to the clients, the directly connected clients. These are now connected to other NTP clients, and let's say these are connected to another NTP clients. So the one who are directly connected, they will be the first point of contact. So all the NTP packets will be directly sent to this. Now it depends on this device. Okay, so this device is sending, but might be there is some packet drop over here, right? We never know, because this interface might have some layer 2 issues or layer 1 issues, cable issues. So might be there are some packet getting dropped, or the interface is not processing out. So timer till here would be good, but there could be chances the timer over here might start falling behind, because the packet, NTP packet, if it just gets dropped, okay, so you lose the reachability and the clock gets falling behind. And now over here it's totally worse scenario now, because you do not have packets over here, and let's say if you still have a problem over here, so basically the clocks on every hops will be showing as different point. Okay, so the best practice is keep your NTP server in such a way that all devices are like one hops away, so that you don't lose the NTP packet just because of interface issues or latencies issues or a cable issues. Okay, so let's say I have NTP server, I have a router, okay, and on the other side I have some third party logging tools. So basically, what is the purpose of NTP and how does it work? So on a router, I have three different mechanisms to capture the traffic. If there is some alert with respective to some interface, you are gonna get triggered with the help of SNMP. Okay, so there are three mechanisms. We will discuss this: syslog, netflow, and SNMP track. So basically, these are three mechanisms which is gonna be used for your understanding. So if let's say one example, okay, the first example being the knock guys. So if you remember how does a knock team works, so they have those LCD monitors display and they get to see all the alerts being sent, right? Knock team networking. Yeah, so if you see these kind of monitors, so basically these tools are receiving alerts from the network devices, routers, switches. If the CPU is more, you start getting alert on your system and you work on that, or you pass it on to your next engineers, right? So that's because you have configured SNMP traps and your device are sending them. Okay, and if you do not take care of your timers, then the engineer, whoever is trying to troubleshoot, might be he will see a very outdated alerts. Might be that's a latest alert, but if your NTP is not updated, then eventually everything starts taking up whatever the wrong time or clock is set, right? So NTP is like your starting point of these syslog messages. If you don't have this, probably you will also have a lot of wrong things set up here. Okay, so that's why I placed this image to show you how NTP is gonna help you in other way. Okay, while having troubleshooting or those, might be you get very less chances to fix NTP or troubleshoot on MTP, but having NTP is important to have your other things which will help you in other troubleshooting, like BGP troubleshooting, OSPF troubleshooting, which is oftenly seen in enterprises, or any kind of interface issue, right? So all these alerts are dependent on this, and these are dependent on NTP. So that's forming like a chain system. Okay, as I told, we can have internet acting as a NTP server as well, but that's again up to internet. If you lose the connection, then probably that's not a good idea. Okay, NTP stratum. What is NTP stratum? It's the reliability. Okay, so it defines the distance from the reference clock, or also we call it as reliability. The stratum of 0 is assumed to be the most accurate, okay, with no delay. So as I told you, atomic clocks, but we don't use this, so we cannot use it. That's true. So a device with NTP stratum value 1 is accurate device. So if 0 is not usable, then 1 is the one which you can use it. So by default, your routers are gonna take 8. but yes, you can set it to 1 and you can start configuring the other devices. Okay, so one is when, so if I have a router, if I have a internet or a atomic clock, and if I see automatically my stratum value getting to 1, that means I'm very much connected towards some atomic clock or a internet, right? Because I'm receiving the stratum value of 1, which is the best one, because 0 is not possible. Okay, 0, I can say 0 is here and 1 is here, might be the next one get 2, might be the third one get 3. So that means I'm very closely connected to one of the best clock in the world. Okay, where does 8 stand? 8 stands somewhere here, which is by default the NTP of your own router's hardware. Okay, but yes, if I don't make use of this, I can customize that to 1. Okay, I can just make it 1 so that all next devices take 2, 3, 4 and so on. You can also have multiple NTP servers. If one goes down, the other takes up, but the preferable one is one with the lowest value. Okay, if there are 3 servers, the one with the lowest value will be considered as the server. This is something which I talked while saying hierarchy model. Okay, so this is a NTP architectures. So it says NTP uses stratum value 1 to 16 to define clock accuracy. The lower is preferred compared to higher accuracy, or a lower is considered to be having highest, and 1 to 15 are in synchronized state. 0 is not used and 16 is not used. Okay, stratums are like TTL number, decreases every hop by a packet. Okay, so I gave you 2 resemblance. One is hops. Okay, if I say this is 1 hop away, this is 2 hops away, and so on, you have the third hops away. So you can also call it as in a hops, or you can also say that you're sending a TTL, time to live. Okay, and you're just decreasing it by 1 hop. So let's say you sent 3 TTL value. Okay, so it just expired by 1, it becomes TTL2, and it still decreases by 1 more hop, it becomes TTL1, and finally it expired. So the way you want to remember this, so it's very simple. You can just take it as in a hop example, or you can just take it as a TTL which is getting decreased by 1. Okay, so over here I have different NTP modes, which is the important topic from this syllabus. Okay, NTP modes. So yes, there are 4 ways, or might be you have heard 3 of them. These are the 4 ones. Okay, so the first one, server mode. Second one, server client mode. Third one, client, and the last one is peer. Okay, so let me just draw one example. So let's say if I have this acting as NTP server. Okay, I have another device and I have other devices. Okay, so this is gonna be NTP client, which I'm aware of. Okay, but this I'm not sure if this is gonna be server or this is gonna be client. It cannot be server. If it is server, then what is the point of having this as a server, right? It doesn't make sense, because they are after all on a single single cable. I don't have any other reachability, so that it takes up one with a better stratum. So in this case, there is no point of making this a better stratum or something. Okay, So but at the same time, if I configure all the NTP, so basically this is gonna send those NTP packets to this, and yes, this has to forward them further, right? If I set this as client, what is the problem? Client is not gonna broadcast the packets. Okay, so what happens if I make this as client? It's gonna update its own timer, which is getting from which is receiving from the NTP server, but client is not gonna send it to anyone else. So that's the problem. Now you cannot make this as server, or neither you can make this as a client. Okay, so the only option left out is server and client. So if you wanna make this as a, so let's say what happens. So let's say first point here is, or first step here is, whatever you receive here, it must adopt it. So it basically need to have a client properties. Okay, at the same time, whatever you received, you need to also forward it. So that's something of a server property, right? So it is now called as server client. Okay, and you will make a device server or client when you have something else also behind this particular devices. Okay, and you need to forward the NTP further down towards them. So in this case, this act as a server, this act as server client, and these act as a client. Okay, only client, NTP client. Now what is peer? Let's say one goes down. Okay, if one goes down, you can still configure the peer relation. Okay, so that you have the other one still acting as up. So I'll show you what are the commands for this. It's very simple commands. Okay, so let me write some points here. What is each one of gonna do that. NTP server. So the main work of NTP server is to send the packet. Okay, it's gonna send the packet. On which UDP number it's gonna send? It's gonna send to UDP 123. As I told you, there are two versions. So NTP server is a backward compatible devices, or it's having a property of backward compatible. So that means it will start sending on version 4 as well as on version 3. Okay, so it depends on the bottom end devices on what they are configured. If they are configured on 4, not to worry, because your server is gonna still send on 4. If they are configured on version 3, don't worry, your server is also sending on version 3. Okay, so I would say both are being sent. Now on the client mode side, okay, the work of client mode side is just to receive them. Okay, it's not going to forward to anyone, so I'm not gonna write not forwarding in nature. Okay, they are also listening on UDP 123. Okay, you can either have version 3 or version 4. So if you say you need version 3, so basically you are gonna respond with this NTP packet. Okay, the version 4 which is coming here will be getting dropped, because we don't have anyone who is listening on version 4. Okay, okay, and the client, as I told you, it's not going to send okay, client. So let's say client will receive but not forward. Okay, but since I have a server role, it's now forwarding as well. So I can just strike this off. Okay, it will receive, it will forward, it will adopt. Okay, and yes, it's also listening on UDP 123. Okay, and also it's gonna get configured either on version 2 or version 4, version 3 and version 4. Okay, and the last one here is NTP peer mode. Okay, so basically what is happening is, if I have a server, a server client, and two clients here, okay, so I can configure these two in a peer mode configurations of NTP. So basically what happens is, if for some reason you just lost this connection, okay, so they are gonna turn into 16 stratum value, which is unsynchronization status, right? So to avoid that, we can still point these two client to act as a reliable NTP source. Okay, so what happens is, they are gonna follow one other. They are gonna have the synchronization between this and this on while this get failed out. Okay, so it's basically when there is a failure in the network, not a very regular scenario. It's when there is a failure, they start uh, so one can synchronize. Okay, okay, and yeah, the last topic. Okay, so I think I have NTP master. So NTP master is NTP server. It's basically to make authentication on the server. Okay, or I can say, while you have multiple routers, so you wanna make one of them to be NTP server, right? So you selected this as NTP server. So basically you're authorizing this person to send version 3 and version 4, while the other routers are only sending one kind of NTP version, either 3 or 4, whichever you configure. So they are also referred as NTP servers. Okay, NTP. So basically, if you're making use of hardware clock itself, then basically that act as a reference. And yes, as I told you, you need to define using a command that this is NTP server or this is NTP master. Okay, so each one of the different modes, they have to be defined with the help of command. So that's how they start broadcasting and start receiving the packets. NTP versions, there are two versions, 3 and 4. 4 supports IPv6 and 3 supports your IPv4, and they're backward compatible. Okay, so as you know, server is gonna send both of them, version 4 and also version 3. So the benefit of NTP version 4 is that it also by default support DNS for IPv6. There's one more difference. NTP v3 is using broadcast messages. Okay, so this uses a broadcast message, and 4 uses a multicast address. And also your NTP4 is gonna have a increased security. You also have an option of setting cryptography and certificate, whereas version 3 only supports the text. Okay, a plain text, I can say a plain text or MD5. So the version 3 is supporting only text or MD5, whereas the version 4 will support text, MD5, and along with that it's also gonna support the cryptography, which is nothing but it deals with certificates. Okay, so you must have some certificate, and that's how they're gonna have authentication. So that's about the authentication point of view. Okay, and yeah, regarding the security and authentication, which is the last topic of your NTP theory, and then we will do one lab. Okay, so how can you just secure your NTP packet? So let's say if you're introducing a router, and you for some reason uh, for some reason you just don't want this particular router to be synchronized, or it might be this is just for testing purpose, right? So you can secure with using access list. Okay, what are the type of ways to secure your packets? Because if I say I have my devices, okay, so any man in middle, if he just try to analyze these packets, they can probably see everything, right? So sending those NTP packet in encrypted format is mandatory. So there are two ways we can make use of plain text, which is easily decryptable, or easily someone can crack, or someone can understand, okay, so this he is using a password of Cisco or something, which is a plain text. But yes, you can also encrypt plain text with the help of MD5, which is message digest 5. Okay, MD5. So now these MD5 cannot be easily decryptable. Okay, so that's how you're gonna secure your your NTP packets between different devices. See, this is that MD5 which I said. And yes, you have a concept of key numbers. Okay, so you can set your key numbers over here, and that key number also must be configured on the client side. Only then they gonna use that key number to decrypt the packet. So key number should be available. So you use ACL, write ACL wherever you are sending the IP address or range. So you need to apply it to the NTP. So that says while you write ACL, while you write access list, you have to define IP address or a range. Okay, and then you must apply to NTP, that if you need to permit that, or are you trying to deny that. Okay, so behind this statement you must define your networks or IP address, and this statement will be used inside access list. Okay, so this is access group command has these option ordered from least restrictive to most restrictive. Okay, so that's nothing but it says that you can have orders. Okay, if you want one of the network to be preferred, the others to be denied, so you can make a sequential order and you can configure them. So this is very simple topic. Just go through once again. If this is your first time, might be some points you might have not understood. So just go back to the video, or once go back to this PDF, which will help you to understand. Okay, it's a very straightforward topic, just with few topics only. Okay, so regarding the lab, so let me tell you what is happening. So for the first time, I'm moving towards to the extreme top left. Okay, so I have a layer 2 switch, which is just used for packet, or used to connect the 3 devices. So nothing is getting configured here. So my first router is acting as the NTP core. Okay, and this router is directly connected to the internet. All right, and I have 2 clients, client 1 and client 2. So basically I need to first do the initial interface config, and then I must make use of the modes. The first, the top one, this router, so he gets the role of server, this one gets the role of client, and this becomes again a client. But yes, I can just make this server client just to understand what happens. Okay, we will do all the 3 configuration to see what is what, and how the packet flows. Okay, Yes, there are some other things here, like to see the authentications. How do we set the key to make use of access lists? Okay, and yeah, so something all this kind of work around. Okay, so let me start up these. So since I told this is not really used, so I'm not taking the console of it. It's just used for connection, the three devices. Okay, and yeah, one more thing, even though I'm connecting to internet, but I will still configure a hardware stratum value. Okay, because I would prefer having the hardware stratum value instead of referring to the internet. But yes, I will still show you how we configure to the NAT and how we get an IP address. So let's say I go to E0/0, I say IP address DHCP, no shut. Okay, and meanwhile let's configure 0/3. You have IP address of 192.168.1.98.255.255.255.0, no shut. Okay, so I'm talking about this one that's configured. Just the basic interface IP, nothing much. Still I have not configured NTPs. Okay, so I go towards my NTP client 1. So might be in the next class, what I'll do is I'll also bring this syslog up. Okay, because today it's almost time. I cannot show everything. So in the next class, I'll also bring syslog. We will enable some loggings. Okay, pointing from this to this. We can just bring down one of the interface, so the logs will be started collecting on this. At the same time, we can also try to do a lot of things with NTP. If I just change the timers, or if I just play around with the timers, you will see the syslog messages also get changed up. Okay, so that's different topics. So one is syslog and one is NTP. We also have a lot of topics here like SNMP and NetFlow. We have span. Okay, so these are all a few topics which will help you for the basic monitoring, troubleshooting, all those things. Okay, so on my NTP client 1, I am going to configure my interface GI0/0, IP address 192.168.1.99.255.255.255.0, no shut. Conf t interface GI0/2, IP address 192.168.1.255.255.255.0, no shut. Okay, so all interface configured. Now what is my workbook says? Now my workbook says the NTP config starts from here. Okay, so if I see my first device, if I just follow what is written, if I make use of the show calendar, so it says some time. Okay, I'm not sure what is this 2029, but yeah, that's fine. Okay, what about other devices? Okay, so they are 2020, 2020, and over here it's 2029. Okay, so let me keep something which is realistic instead of some wrong values. And how do I change the clock? It's just a single command. Okay, I don't have to go to config t. It's still gonna take from the user executive mode. Okay, enter this, and if you do see the show clock, so it says that clock update has been done from the console. Okay, so you see the right time, right clock that we set is June. Okay, you can also change the time zone. Okay, right now it's by default UTC, but you can change them. So you can go to conf t, you can say clock, time zone, and you just need to give the word. Okay, so basically this is a word. And where do you get this word? You can get it from online. So if you just clock, time zone, okay, you just enter, you will see almost all the time zones, different time zones. So you see, this is the format that you need to enter for time zones. Okay, so in case of UTC and whatever they follow plus 3 or whatever, if it is IST, then it should be UTC plus 530. Okay, so let's say we have made use of some values here, time zone UTC plus 3. Okay, and if I see do show clock, so now it says 421 UTC. Okay, earlier it was something else. So let's say we are on a right timestamp now. This is the right timestamp. Okay, and if you just compare with other devices, they are on a let's say they are running on a different, but actually they are the right one. They are on June 23, but since we are doing NTP lab, I just want to show you that how this works. Okay, so that's the first step of configuring clock manually. Now you go to the server and make use of the master command and give the stratum value. Okay, so if I just see show NTP association, so they don't have any NTP configuration. What is status? There is no NTP configured, it says. Okay, so I'm going to config t now. I'm gonna say that this is a master. Okay, you know NTP server is a NTP master, so I'm gonna say he is a master. What is the stratum value of a master? So I have mentioned it's 3, so let's take it as 3. If I do question mark, there are a couple of options. Okay, so one of them is to make your loopback as the source, because you know the loopback never goes down. Even if your physical interface is going down, you still have that loopback running up, right? But yes, I don't have any loopback configured at the moment, so I'm not going to configure this statement. If in case, let's say in production or in your lab, you just bring one of the loopback, you can set this, but this is a optional command. Okay, this is not a mandatory command, it's an optional command. So let's say I move on to the next command, that is this command. Okay, so let me see from my diagram. So which is that interface? So this is the interface where I need to do some changes. Okay, E0/3. Okay, so let's say I go to interface E0/3 and I say NTP broadcast, because this is a master and the packet must be broadcasted. Okay, so if you want to see the packets now, you can see on Wireshark. So you just filter out with NTP. Okay, so meanwhile it just start appearing, we just do further more commands, okay, and then we will see this. So it says NTP clock, and if I do make use of show clock, so I see this is the right clock. If I make use of show NTP status, it says clock is synchronized, stratum is 3, reference is its own hardware. These are all the frequencies of the timer, all the analog messages, all those things, which is not very important from network engineer point of view. Okay, you only need to see that clock is synchronizing. Okay, let's see what is it associated with. So it's not associated with any other clock because he himself is the master or a server, right? So he's gonna give reference to himself. He's saying that I am myself is a local reference clock for other devices in the enterprise. Okay, fine. So that was with respective to NTP server. Okay, and also there are few commands like show NTP packets. So you see there are 2 packets being sent. So did we get them? Yeah. So yeah, we got some packets, right? So what are the packet? The packet is NTP version 4. So as I told you, the server is gonna send version 3 and version 4. So you can see version 4, okay, and same way you will also see version 3. So let just wait for that. So you will see version 4, 3 and 4. That's a property of this. So you can see how many packets were sent. So packets sent will be easy on a Wireshark to analyze. Okay, status I showed you, association I showed you, packets yes. What about information? So it's just some values which is automatically getting populated. Okay, so NTP is gonna calculate. Now what is my task? So I say that this is a server, this is server client, and this is a client. Okay, so let's move on to the server client now. So my first device is now server client. Okay, and how do we configure? That's over here, NTP server client. So I go to conf t, I say NTP server. Now who is my server? My server is this IP. Okay, this is acting as the IP of the server, the NTP server. And where is NTP server referencing to? Its own hardware clock. Okay, so just understand that for these client, this IP is acting as a NTP server or NTP master. But where is NTP server or master getting the source clock? It's either from internet or its own hardware clock. In my case, I just did on my own hardware clock, right? So it's referencing to its own clock. So let's say NTP server is 192.168, okay, and 98. So what else do I need to set? So I can also set the version. So let's say I am following the version 3. If you know, we have 2 versions. Okay, so basically there are 4 versions, 1, 2, 3, 4. Cisco uses 3 and 4. Okay, the other 1 and 2 is utilized by some other vendors. So we majorly use 3 and 4. 1 and 2 are obsolete, or I can say they are not widely used. Okay, so as of now we use only 3 and 4. So let's say I make use of version 3. Okay, so as soon as I make use of version 3, you will see there is a backward compatibility. The server is now responding back on version 3. Okay, so they are, you can see how the packets are moving. So they are on forwarding on a source and UDP 123 packets. So this is a source and destination. This is a UDP packet, okay, and this is the NTP data packet. Okay, I just forgot to see the yeah, I have shown you, right, what is the clock. June 20. So is this the clock that it's following? I think I should have made use of some different clock so you guys could have understand, right? So it's not too late, I can still do the change. Okay, so let's make it as different clock so that we can see the difference easily. So I'll make this as 1995. Okay, so it says it is configured, so the next NTP update packet will synchronize that. So we can see that whenever the next NTP packet just comes. Okay, so it will take time. I told you that this takes some time, so it might take 1 to 2 minutes. Yes, we can also enable NTP packets. So you have some packets. So it will take some time. Okay, it will take some time and we can see the changes. Okay, so yeah, so what did I get? Okay, not an issue. I'll continue for now and we will see after some time. Okay, so that was for a server client, very simple configuration. And now from client point of view, okay, the second router, NTP client 2, act as a purely client. So when you have a client, it means that you're just taking the NTP, adopting it, but you're not forwarding it to anyone else. So you need to exclusively define that it's a client, broadcast client. Okay, whereas in server client we have not defined that, but in the client we need to define that single command so that it doesn't send it to someone else. Okay, so I go to conf t, I say NTP server is 192.168, and what is my clock here? It's on 1.98. Okay, okay, so it's a typo here. Which packet I'm trying to send? I'm sending packet 3. My interface, that's 2/0, that is this interface, has to be set to broadcast client. So I say interface GI0/2 NTP broadcast client. Okay, so yes, we can also take the captures here. So let's meanwhile see if that router has started adopting. Okay, so let's see show clock. Okay, not yet. I'll do one thing, I'll just bounce the port. Okay, so let's see show NTP association. So it's associated with the rightful clock. Okay, 1.98. It takes sometimes time. NTP are very slow actually. So you see here it has been changed on one of the router. Okay, the second router, you can see it's started reflecting the same thing which you just configured here. Okay, so the difference over here is just because you changed the UTC timer. Okay, you customized something out of the box. That's the only change. But yes, the packet has arrived here and it started taking the or it started following the NTP server. I'm just trying to see if this also follows the same pattern. So it says it received some message. Let me change to something else. 2005. So let's wait for some time and let's recheck once. Okay. So they will be not instant. Okay. You need to wait sometimes for 45 to 1 hour. But the main thing that you can see is the alternative commands like associations, which is going to help you. You can also see the packets that's incoming and outgoing. So you see that they are good number of packets. Okay. What else can you see here? So let's see what is status. Okay, the status says it's not non-synchronized yet. Okay, that's might be the reason the clock is not synchronized. So it takes time in the case of NTP. So make sure the packets are in and out, and you can see the NTP association, which is fine. You can see uh, the stratum value is 3. Okay. So you have your server stratum value 3. So these are all other things like regards to the timer. Okay, how many packets, all those things. So you can see the packet performance, jitter, dispersion, offset. So these are related to uh, the clock frequencies. Let me once bounce the port. Shut and no shut. Okay, so anyway, so we have already checked how the clocks are gonna work. Okay, so might be this is taking some time. Okay, just try to redo over on your lab, follow the same command, and you will see how it works. Okay, so from the packet tracer level, so you can see the server client messages. So server is your NTP master, and client is those access layer switches. So you can see server sends. So if you see from the source 198 point of view, it will send both the packet. It will send version 3 and also it will send version 4. The rest of them, like clients, will only initiate only those messages that you have asked for. If you set version 3, then it's gonna only take version 3. Okay, so what else we covered? We covered NTP. So we also checked what is NTP peer, right? Theoretical, we checked what is NTP peer. I'll just show you how we configure this. So NTP peer is a status, or it's a relation when if one goes down, the other act as a synchronizing, or other provides the synchronization to the other. Okay, so let's say if there is any issue with this to get something, so basically this is gonna act as now the NTP peer who is providing the synchronization. So it's once again easy commands. So you have NTP peer commands here. Okay, so I go to the config mode of my clients. I say NTP peer. Okay, so on the other side, what is the IP of its interface? So this is the interface. Okay, so if I show you here, this is 100 and this is 99. So I say NTP peer 192.168 1.100, and what is the version? NTP peer 192.168 1.1, it's version 3. Okay, similar way I go to, okay, I think I did a mistake on this, so it should be 99 for this. Do show run peer. Okay, so let me first take the first client. Okay, so it will reduce the confusion. So on the first side, NTP peer is 192.168 1.100. The version number is 3, and on the second side, NTP peer 192.168 1.99 and version is 3. Let's see if we see any changes. So you can see the association now, right? So earlier we were only having a synchronization with the main server, but now I have a backup also. If the server goes down, still my peer can act as a synchronization factor for me. Okay, so if you see this, I still have 98 as a main one, but do not worry, if this goes down, you still have your second peer which is in init state, initialization state, which will start acting as a synchronization. Okay, at the moment it's on 16, otherwise it would have been 3, 4 or anything else. Okay, so just exclude this value as of now. This 16, as you know, stratum is a not good value, but do not worry, it's because of the slowness. Okay, it takes some time to get settled down, sometimes 45 minutes, sometimes 1 hour. So after sometimes it gets settled down. Okay, so this is how you referring to two clocks now, and if you see on the second box, so you can see 98, okay, which is your server, and on the other side you have 99. And what is NTP status? So might be it is still unsynchronized. Okay, not an issue. Okay, so that was regards to peering. Let me also quickly show you the authentication, which is very straight and forward. Okay, so what you need to do is you need to first set a key on your core router. So you say NTP master. If you do a question mark, so let's say you are setting the stratum value. Okay, make enter or press enter. NTP authenticate. Now you need to set a key. Okay, so any key between this range. So let's say I set up as 1. Okay, if I show you the packets, so you see this, there is no authentication at the moment. Okay, so they are just plain, they don't have any authentication. But once you set, you can see that these all are now authenticated. So if I open up the packet, so basically they do not show. It's your TCP packet which you can actually see it. Okay, UDP packets you just cannot see it on a Wireshark. So let's say I set up a key value, enter, and now I need to define the password. Okay, so NTP authentication key 1 MD5 and any authentication values or authentication key. Okay, so I say it as Cisco 123. Now this is the main key, okay, which you need to have it on all of the routers, and that should be very unique. You cannot have dissimilarity or different copies of them. So you created your key, you created your the password. Now you go to the client side and start pointing them. Okay, say NTP server, which is 192.168 1.100. So what key number it has? It has a key value of 1. Okay, you're gonna say NTP authenticate. You're gonna say NTP trusted key 1, and you are also gonna set what is that key value for that. Authenticate key 1 MD5 Cisco 123. If you make a mistake, then they will not get synchronized, or there will be no synchronization between them. So almost very similar command is with respective to the NTP peering also. Okay, so if you remember, as of now I only did between server and this client. What about this now? The peer authentication, right? There also we in our lab we have also formed a peer neighborship. So I will also have to authenticate this too. So I go to my first router or the NTP client 1. I say NTP peer, which is 192.168 1.100. Okay, this one, and I'll set all the key and the key values. I say key 1. I make use of NTP authenticate. I say NTP trusted key 1. Okay, so it says that key is already been created. So you don't have to execute these two commands. Okay, just setting up this will be enough. Only one statement, because you have already created the key in your previous example or in the previous step. So on the second client, do make use of the same thing, NTP peer 192.168.1.1 key 1. Okay, and NTP authenticates. So basically, you don't have to do once again the key 1, define what is the password. So the password is Cisco, okay, not test. Fine. So that was regards to authentication. But I told you there is something called as ACL, which will help you to secure the packets or filter the packets. Okay, so I say that this should be permitted. So in that case, only this is gonna be getting permitted. Okay, so if I go to the client 1, if I make use of access list and a access list number, I'll make use of a standard access list. I say permit, and I make use of 192.168.1.98. Okay, and before this I also have to configure some parameters. Okay, this first regards to access list. Now let's say I have on my core access list 1 permit, and I just make use of that some word. Okay, let's set some word. So let's say 8.8.8. I say NTP access group peer 1. 1 is nothing but this line. Okay, I set it up. Now let's say access list 11. So I'm just setting up my client. I'm gonna say that I am a server only to these two clients, not for anyone else. This is all security terms. If you don't want any third device coming up all fine day and it start getting the NTP packets. Okay, so you're setting up the access list. You say access list 11 permit, and the two clients in the lower stream or the downstream 192.168.1.99. okay, so access is 11.190. okay, there's something missing here. Okay, it is 1.99 and 1.100, and you say NTP access group serve only whatever you wanna make active. Okay, so you say NTP access group serve only 11 because you defined the access number to be 11. So this is how you are you're implicitly defining your access or the NTP server. Okay, so if you have this server, you have your two clients, so you're configuring ACLs here, saying that you're just permitting these two clients only. Okay, no other will be allowed to get the NTP from this. Similar way, from client point of view, you're just trying to become a client for only this server. Okay, so you say that I'm forming a permit with only 98. Okay, so I'm forming the NTP relation with only this. If I get some other devices, let's say it has a better stratum value than this, then even then this is not gonna take or get that clock as to be preferred. Okay, so this is ACL way to just block and permit any possibilities of NTP changes that can lead to some issues. Okay, because you never know, you get some devices with better stratum value and everything start polling from that. So you just are going with the ACL method to restrict all those unwanted circumstances. Okay, so that's something about securing them. Yes, these are some verification things, and under show NTP association there is a huge table. So let me see what are those. NTP association, Okay, so over here, first of all, it's regards to what are these, uh, what are the meaning of those. Okay, so synchronized to this peer, almost synchronized, all readable things which uh, I can let it, uh, or I can just give it to you guys so that you guys can understand. So these are the code words or the code, and what are they justifying. Okay, so it's basically over here which I have mentioned. You have address of the peer. Now in this case, this has its own hardware clock. Okay, so the peer is nothing but its own local IP, or a uh, local link address. Okay, 127. So what is 127 address? So if I make use of classes of IPs, so it's a reserved IP 127. Okay, so if you just see over here, you have ending 127 and the next starts at 128. So anything between this 127.xxx till 127xxx might be 99, okay, or 255. So between this, the links are, or the IPs are called as reserve, or a link local, or a loopback we can call it as. Okay, so if I show you 127.x.x, so they basically are reserved for loopback address. Okay, so there are a couple of IPs which are reserved. So you see here, this is your own internal IP address. Okay, what is reference clock? It says local. So basically I'm a server, and I'm having my own clock, so it's gonna refer to local. Stratum value is shown as 4. This is the last NTP packet that it received. This is the polling interval in terms of seconds. This is the peer reachability. Okay, peer reachability in the bit string. Okay, this is the delay for your packets, for the round trip of your packet. This is the offset time of the peer clock. Okay, so basically deals with the clock. Okay, might be we do not understand it. And this is dispersion. Okay, so basically these are the meaning of this. This command, which is important, which will tell you if you receive the packets or no. So you have plenty of them. Show NTP status. It says synchronized. So let's see the other ones. Okay, now since I've configured authentication, might be if I've left out on some, then of course they will not come up. So I guess this has come up. Okay, show clock. Okay, yeah, see, it has come now. 205, and if you see here, 205, right? Now it synchronized. So you see how much time it just took. So show NTP association. And there was one more command where it was showing us to be unsynchronized, right? So let's see that. Yeah, now it is synchronized. Okay, it says clock is synchronized, stratum value is 6. What is the stratum value here? So you see stratum value of the server is 5. So yes, gradually the next one will be one hop away, right? So it will have one greater number. So which is better? The lower one is better. So if you see stratum value 5, that means this is server. So I can also prove that. So you see it says stratum value of 4. 4 is nothing but referring to its own internal clock. Okay. So yes, that means it started with 4. The router or the server is acting as 5, and its next immediate client are acting as stratum value of 6. So you can see the stratum value is 6 and the referencing is happening to 98. Okay, the server. Let's see from the second client point of view. Show clock. Yes, it is also getting synchronized, but let's confirm. Yeah, I guess so. It's getting synchronized. So let's to show NTP association. Okay, so let's see NTP status. No, this is not yet. Okay, so might be it takes some time, or might be since I configured the authentication, the passwords and all those, might be if I missed one of them. So yes, it will not come up. Okay, but yes, you yourself just saw how much time it just took for one of the client to come up, right? It took like 20-30 minutes for it to get synchronized. So it takes time. You have other ways to check, so don't always trust on the date. Okay, it might take time, but yes, you can see packets, NTP packets. You can also see NTP association. Okay, which will help you to understand. Okay, and these are some debugging commands. So yeah, that ends this topic, NTP. So as per syllabus, just describe, which was half an hour of work. Might be could have finished it long back, but yes, doing a lab proves a lot of things, so which might help us during some troubleshooting or something else. Okay, so let me know if you guys have any doubt. So no doubt all are good with NTP. I guess you might have already worked on NTP or you're aware of NTP topic.